cradle because she has to keep rocking the cradle 24/7. She can have a rest.
Well, good morning everyone. We are very excited to present our new innovation, the Smart Baby Cradle. We know that baby sleep quality is heavily relies on two critical factors. The first one is comfortable thermal environment and the second one is consistent stable motion. The problem with traditional cradle is that they rely on manual input, which is inconsistent. This creates a jerky movement that trigger baby stutter reflex and disrupt their sleeps. Furthermore, a lack of air circulation leads to heat buildup, causing discomfort to our baby. Why is this a physics problem? First, regarding to the rotational dynamics, we treat a cradle as a mechanical system by precisely controlling the torque and ensure a constant angular velocity. This eliminates the jerk that's found in manual rocking by allowing for a smooth transition that keeps the baby calm. Second, we address thermal physics through three heat transfer. The first one is conduction, the second one is convection, and the third one is radiation. By treating a cradle as a controlled environment, we are not just rocking the baby. We're managing two physical variables to create a comfortable, safe, and stable sleep for our baby.
Hi everyone! I want to talk about our product improvement. Before that, I want to show picture traditional baby cradle. For our product improvement, we developed a smart baby cradle by upgrading traditional baby cradle with smart technologies that improve motion control, temperature regulation, safety, and convenience. Important components is the electric motor. The motor generates rotational motion automatically without manual effort from parents. Next is the gear system. The gear system controls the rotational speed and increase torque. This ensures stable motion and improves safety. Other than that, we have temperature sensor. Continuously measure the surrounding temperature, help maintain a comfortable sleeping environment. So, have a cooling fan. When temperature become high, fan circulate air around the cradle to remove excess heat. Make baby comfortable. Final component is smartphone monitoring. This feature allows parents to monitor and control cradle using a smartphone application. It allows parents to ensure their baby's safety. In terms of physics, this product applies two important concepts. The first is rotational motion, where torque and angular velocity produced by the electric motor. Gear systems are converted into swinging motion through the crank mechanism. Second is thermal physics, where heat is detected by the temperature sensor and reduce convection cooling by the fans to maintain a comfortable environment. System operation. First, parents select the rocking speed using smartphones. Next, the electric motor starts rotating and produce torque, while rotational motion transfers to the gear system. Gear system adjusts angular velocity to ensure smooth movement. As the result, the cradle swings from side to side. Meanwhile, the temperature sensor continuously monitors the surrounding temperature. Finally, the cradle continues operating automatically while maintaining comfort and safety. So, where is rotational motion and thermal physics applied? Rotational motion is applied in the electric motor and gear system, where torque and angular velocity are produced before being converted into swinging motion by the crank mechanism, which is convert rotational motion into oscillating motion. Other than that, thermal physics apply in the temperature sensor and cooling fan system, where excess heat is removed through the convection cooling to maintain a comfortable temperature.
Assalamualaikum and hello everyone. I will discuss how core physics principles are applied in our smart baby cradle to ensure the most comfort and safety for a baby. Okay, first we apply the concept of torque, which is the turning force that causes the cradle to rotate. So this is the equation for torque. Here R is the distance for the rotational axis, F is the applied force, and theta is the angle between the force and the lever arm. In this system, the electric motor generates the necessary torque to initiate and maintain the rocking motion. Without the sufficient torque, the motor cannot rotate and the cradle would fail to swing automatically. Okay, so next we control the speed of the cradle using angular velocity. So this formula for angular velocity, where the theta delta is the angular displacement and theta t is the time taken. By adjusting the gear system, we can set different speed, such as low angular velocity provide a gentle motion suitable for newborns. Medium angular velocity offer the most comfortable setting for daily use, and the last high angular velocity provide faster motion used only when required. Okay, for third physics principle is angular acceleration. To ensure the cradle start and stop smoothly, we manage angular acceleration. So this is equation for angular acceleration. If acceleration is too high, sudden movement occur which may disturb the baby. Control acceleration ensure a smooth transition of motion, providing a safer and more comfortable experience. Okay, the last physics principle for stability, we focus on the moment of inertia. So the equation for moment of inertia, where m is the mass and r is the distance from the rotational axis, proper mass distribution ensure the cradle is balanced, reducing vibration and improving stability. We also strictly control angular acceleration by ensuring a smooth transition of motion. We prevent sudden movement that could disturb the baby's sleep.
Let's look at how we apply thermophysics to keep the cradle environment perfectly balanced. Since babies have less developed thermoregulation system, they are highly sensitive for temperature shifts. Our design tackles this by utilizing 4 core principles simultaneously. First, convection occurs through direct contact with the mattress and fabric, drawing heat away from the baby's body to prevent heat accumulation. Second, convection is managed by an integrated cooling fan, which is a gentle continuous airflow to replace the stagnant warm air with a cool breeze. Thirdly, radiation allows the baby to naturally dissipate thermal energy into the surrounding space. Together, this mechanism achieves thermal equilibrium, a perfectly balanced state where the heat entering the system equals the heat leaving it, ensuring a stable sleeping climate for the baby. Let's look at a prepared video. While traditional cradles require exhausting manual rocking, our smart cradle automates a perfectly smooth turn. Our focus here is entirely on optimizing torque and angular velocity for total structural stability. Next, the thermal animation shows the exact moment the sensor detects heat and triggers the fan to safely restore the equilibrium. Do you know that most automatic cradles on the market only focus on basic motions? Our smart baby cradles deliver a holistic solution by prioritizing motion stability, thermal comfort, and sleep quality. To conclude, this innovation does not simply automate a cradle. It also meticulously applies the principle of physics to safeguard and nurture the next generation. Thank you.
In terms of safety, the cradle provides controlled motion safety through smooth and stable rocking without sudden jerks or speed changes. It also offers thermal safety by preventing overheating and maintaining a comfortable sleeping environment. Furthermore, the cradle is designed with a strong and stable structure, reducing vibration and ensuring safe operation. The project also achieved several positive outcomes. The cradle produced consistent oscillation, stable movement, improved motion control, and reduced vibration. At the same time, it maintains a comfortable temperature with proper airflow and balanced heat distribution. These features help babies sleep better, feel more comfortable, and experience fewer disturbances. Parents also benefit from reduced workload, greater convenience, and improved efficiency. What makes this project unique is the integration of rotational motion and thermal physics. Rotational motion provides controlled working through stable angular movement, creating a calming effect for the baby. Thermal physics help regulate temperature, maintain thermal equilibrium, and remove excess heat, ensuring comfort throughout the sleeping period. Together, these two physics concepts improve sleep quality, safety, comfort, and overall efficiency. In conclusion, the Smart Baby Cradle demonstrates how physics can be applied to solve real-life problems. By combining rotational motion and thermal physics, it creates a safer, smarter, and more comfortable environment for babies while supporting parents in their daily responsibilities.
That's all from us. Bye-bye!